Okay, so I'm David Goldman, and this talk is going to be about tweak development with a little help of my tool that I made, InspectiveC. So a little bit about me. I'm from New Jersey. I'm a 20-year-old student there at Rutgers University. I started JailbreakCon in late 2012, started coding tweaks relatively recently in 2014, and I'm known for all the color tweaks basically in the world, color flow predominantly, and some other tweaks, most recently InspectiveC, which is a tool that you can use to develop your tweak. So hopefully a few of you here are interested in making a tweak, but you don't really know what you're doing. So hopefully this talk will help explain what you should be doing and how to do it. So first things first, you're definitely going to want to have some Objective-C knowledge. If you don't have any Objective-C knowledge, it's going to be relatively hard to do. When I first started coding color flow, I had no idea what I was doing, no Objective-C knowledge, just a little bit knowledge of C, and it made it really difficult. Basically, all the code that I wrote originally was basically crap, and I had to fix it later. So don't get yourself into technical debt like that. Definitely learn Objective-C first. I also definitely recommend having a Mac. With that one, it's possible to make a tweak, but it's really annoying. So just get a Mac and it'll make it a lot easier. One more thing, you definitely want to have a lot of free time to make these tweaks because it's a lot more complicated than it looks, and you have to do a lot of research. So be prepared for that. Here's the next step, what tools you're going to need to make a tweak. First things first, you're going to want to search the internet. Crazy, right? You have to look online for the Objective-C headers. These can be found on GitHub, such as that link right there. You could also go to Limnios, developers.limnios.net. That's a really good place for you to look. Basically, you're going to look at these headers and try to figure out what an app is doing with all this stuff. Next thing, my personal favorite tool is called Flexible. This allows you to do a lot of fancy things at runtime. You can basically inject into an app and view the entire view hierarchy, view by view. You can also inspect and modify instance variables on an object. Basically check out an object, see what methods are on it, and basically call them. You can also explore the heap, which is the image there to the right. You can't really see it, but it's listing all the objects in the current process. I think it's Springboard. And this is available on Cydia for free. Here are more pictures of it. I'm just going to skip over this for now. You can look at the presentation later. It's basically very useful. Another tool that you can use is disassembly. You can use something called Hopper or IDA Pro in order to disassemble. Basically, Sorg mentioned this earlier, something similar. Basically, he mentioned a very small insight into disassembly when he printed out the assembly. But basically, what you're going to do is you're going to use Hopper and get an idea of what's actually going on by looking at the assembly and look at all the Objective-C message sends, all the branches, and try to figure out what that original source code is looking like. The thing about this is it's very low level, it's kind of hard to do, you need to be experienced with it, so it's not recommended for beginners. So my tool is called InspectiveC, and basically what it allows you to do is filter and log Objective-C messages. So you can basically check what's being called at runtime, figure out what a method is doing by seeing what method it calls, and then also see what calls that method. So getting basically a stat trace of sorts. So the other question that you might have is, why do we bother with all this reverse engineering? So the first things first, without any reverse engineering, you might break things accidentally. So you basically just guess and insert code somewhere into some class somewhere, some method, and then eventually it might crash on you or lead to some unintended side effects. So you can introduce a lot of bugs, right? Color flow, this is a bad example, but color flow has some very odd iOS 8 bugs. You see here. Before I properly updated it to support iOS 8, it looks something like that. You can see it's just messed up, the colors are wrong, the grabbers are inconsistent, you can't see the play pause button. It was just messed up, right? So what I used to fix that was with a tool called Flexible, which I spoke about earlier. Basically, I just looked at the views and saw that something was wrong. There was a compositing filter set, and that was that. But the buttons, on the other hand, something very odd was going on with them, and Flexible couldn't help me there. So I decided to make my own tool, InspectiveC. So the goal with it was to figure out what was going on with that button, and like other objects, other classes that operate in the app. And then it should be easy and fast to use, so I could easily just, temporarily load InspectiveC with my application, and then later on just take it out when I'm done with it. The core features of Objective-C are you can log and filter Objective-C messages and arguments, like I said before. You It basically allows you to see how a method works without going to any assembly whatsoever, and you can also see what calls a method without LLVM at all. Then it also does include multi-threading support, so you can use it in like games and stuff. Something like a search engine has a lot of different threads going on, you can log all of them. So here's a little bit technical part of InspectiveC. Basically, it hooks into the Objective-C message send method on ARM64, and then it just checks the arguments that that method receives, and then filters it and logs it as necessary. This was actually based off of InspectiveC. I trained for first InspectiveC by Stork, and then Objective-C by NPM. So coding this originally for ARM32 wasn't hard, but I recently ported it over to ARM64, so now it supports all your new phones. Here's some example code for InspectiveC. If you're a developer, you can look at this and probably make sense of it. The only thing that you probably won't understand is the set maximum relative logging depth. That basically prevents it from the logs from being too complicated as it nests down, and I'll show you that in a second. So basically, when you filter a method, it'll print out whatever happened before that method, and then whatever happens recursively inside that method. So on the next screen, you'll see that I watched Springboard's run method, and then you can see everything that that run method called or cropped. But the first thing it did was it called NS auto release pool, which then did out of the zone. Then it did accessibility init, which is from all other methods that just got kind of complicated. Then I cut it off there. But yeah, you can get a really good idea of what's going on behind the scenes. So here's the general use case for InspectiveC. Basically, you log what you want, then you go read the logs, and then hopefully you can figure out what's going on, and then use it to make your tweak. So now I'm going to go over a basic dev flow. I presented this linearly in the slides, but it's really not linear. It's basically a concurrent process of just like doing everything at once and trying to make sense of everything, trying to make it tweak. So, like I said before, you're going to want to use Flexible and search for headers online to get an idea of what's going on inside the app. So then you could write your tweak and inject into it. I would definitely recommend using Flexible whenever possible, as it's very, very helpful. You can do a lot with it and inspect things at runtime without writing any code whatsoever. You're also going to want to structure your tweak, figure out and plan out what should go where, what you're going to need to do if you need to add any classes, create new views, modify existing views. Basically figure out what hooks you need and what hooks you don't need. You're also going to want to use reverse engineering tools if necessary. Hopper is definitely required if you're hooking into some complicated processes, but InspectiveC should suffice if you're doing something that's relatively only involved with Objective-C method calls. Yeah, basically you use these tools, figure out what's going on in the background, and figure out where your hooks should go. And then last thing, you put everything together, and then you test it all out. Make sure you definitely test things out, because if you just hook a method and don't really look into what it's doing, you could easily break things. Like other methods could call that method, and then you return null or something, and then if you reference it, and then it crashes your application. So you definitely need to be careful with that. Yeah, so just keep on reverse engineering as necessary and keep on coding. And that's basically it for this talk. Here's a link to InspectiveC if you want to view the source code. And yeah, it's open source, you can contribute, fork it, whatever you want. Thank you.